everyone, happy Monday. Welcome back to math. This week we're going to move into geometry and we're going to move away from perimeter and area and we're going to move on to shapes and all of the properties that these shapes have. Today we're really going to focus on the difference between a regular polygon and an irregular polygon. We're going to look at some different quadrilaterals and then we're going to go over line of symmetry. And then you'll either log into Edulastic and work on the assignment on there, or you'll do the paper-based. Today you're just matching the shapes with the names of the shapes. Tomorrow we'll get more into the properties and which, we'll just talk about that more tomorrow. So today we're going to start with regular polygons versus irregular polygons. So I'll move you a little bit so you can see. Okay, so the difference between a regular polygon and an irregular polygon is that regular polygons are plane figures with at least 3 equal straight sides and angles. So the word regular, we're going to remember that by just saying equal. Regular, when we look at all of the regular shapes, you're going to see that all of the side lengths are equal. Whereas irregular polygons are figures that do not have all equal sides and angles. So the irregular shapes that we're going to look at today, you're going to go, oh, that's a weird looking shape, because they are, because they're not equal sides. So we're going to first start by going over the names of these, how many sides they have, and then talking about why they're regular versus irregular. So the first one we have up here is a triangle. So a triangle is a shape that has 3 sides. However, a regular triangle is a triangle that has 3 equal sides. So if I was to take my ruler and measure all of these sides, they would be the same. This is an irregular triangle because if I was to take my ruler and measure these sides, they would be different numbers. Okay, so maybe this is 6 inches and this is 3 inches, whereas each one of these is 3 inches. So the difference between regular and irregular is that regular, all equal sides. Irregular, not equal sides. The next one we're going to go on to is a quadrilateral. You might be saying, well, this is a square. You're right, it is a square, but quadrilaterals, there's multiple shapes that have 4 sides, but not all of them are going to have all equal sides. The only quadrilateral that's going to have all equal sides is a square. So that's why you're seeing this one here. This is considered a regular quadrilateral. The other quadrilaterals we're going to look at are all going to be irregular because they do not all have equal sides. So if you look at this shape right here, these 2 bottom lines are much shorter than these 2 lines up top. So this one is considered an irregular quadrilateral. And while we're at it, I am going to go over here and show you some more examples of quadrilaterals, and then we'll move back to other shapes. So other examples of quadrilaterals are, again, we talked about it, a square, because you have all 4 equal sides. A rectangle, again, 4 sides. These 2 are equal, and then these 2 are equal. So not all 4 of them are equal, so this is considered an irregular quadrilateral. A parallelogram. A parallelogram is a rectangle that is just kind of pushed to the side. So if I had this here, and then I wanted to make a parallelogram, I kind of just push my sides to go that way. Parallelograms still have 4 sides. However, these top 2 lines are equal, these 2 lines are equal. A rhombus. A rhombus is the only other shape besides a square that is going to be considered a regular quadrilateral because all 4 of these sides are the same. It essentially is a square, but all I did was go whoop, and move it to the side. So these are all equal. If I took my ruler, they would probably each measure to about 4 inches. A kite. A kite is still a quadrilateral, but it is considered irregular because not all the sides are equal. So these top two are, and then these bottom two are much longer. These bottom two are equal to each other, but not equal to the top. So that's considered an irregular quadrilateral. And then the last one that we have for you is called a trapezoid. A trapezoid still has 4 sides, but the only two that are equal are this one right here and this one right here. This line is much longer than this top one, so it's considered irregular. Okay, now we are going to go back to our other polygons, our regular and irregular ones. So we are now on number 5. 5 is called a pentagon. So pentagons have 5 sides. A regular pentagon has 5 equal sides, whereas an irregular pentagon has 5 sides that are all different lengths. So again, it looks like a silly shape. It doesn't look like a normal one like this. A hexagon is a shape with 6 sides. So this is a hexagon. You see 1, 2, 3, 4, 5, 6. All of these 6 sides are equal, so this is considered regular. Whereas you look at this guy over here and it doesn't look like a regular shape at all. So this is considered irregular because all of these sides are not equal. You can tell because this bottom line is much longer than this top one or any of these other smaller ones off to the side. So it's considered irregular. The last one we're going to look at today is called an octagon. An octagon has 8 sides. So right here, just like you saw on one of your problems the other day, I think it was for a stop sign, this is an octagon. All sides are going to be equal for your regular octagon, and then your sides over here are definitely not equal, so they're going to be considered an irregular octagon. You can tell because this line down here, again, is much longer than any of these little lines that I have showing. The final thing that I want to talk to you about today, and that we've talked about before in class, is, get to see all my neighbors, sorry, is lines of symmetry. I will close this so you can see. So, lines of symmetry. Lines of symmetry is imaginary line that passes through the center of a shape and divides it into 2 equal halves. So I've drawn some examples up here to show you what would work and what would not work. I'm going to get my pen. So for example, in this first circle, you have a line that goes down the middle. Now, if this shape was cut out and I had it in my hands, and I had to fold the paper on the line, this side here would fold over perfectly to right here. So this would be considered a line of symmetry right here, because you would have 2 equal halves. Now, if I folded right here on this line, I'm not going to have an equal line of symmetry because it's not going to be equal here. If I folded this down and over, it's probably only going to come to about here. And we need it to come all the way down to the bottom. For my hearts, if I asked you to fold right here on this line, and you folded this in half, then those 2 would be a line of symmetry because they would be equal. So if I folded it like this and I cut it out, they would be 2 equal halves. But if I cut right here, or if I folded right here, that's not going to equally fold in half perfectly. Another example would be these ones down here. So I'm going to write that yes, this one works. No, this does not. We said no to this one, and yes to this one. Okay, so now if I looked at these squares I have, And if I cut this square out and I asked you to fold it in half on this line, you would have two equal pieces. It would look the same on both sides. So this one is considered yes. Line of symmetry is down the middle. Now if I asked you to fold it right here, you're not going to get very far because this side is much bigger and this is much smaller. So you do not have two equal halves here. So this is considered not an equal line of symmetry. Now on some shapes you might see it cut diagonally, which is what this one is doing. Well, when you do it diagonally, they're still going to work because when I fold this half over, this corner is going to touch here and they're going to be two equal halves of my paper still. Some other shapes that I have drawn is this one down here. This is considered a quadrilateral because it has 1, 2, 3, 4 sides, but it's considered irregular because the sides are not equal sides. So if I asked you to fold the paper right here, it would not fold properly because this corner is not going to match up here with this corner, okay? And then, so this one's going to be a no. This one's going to be a yes. Now, for this crown, if I asked you to fold the paper right here, and I folded it, my spikes to my crown are going to be touching, but they're not touching any other spikes down here. So this is not going to be a line of symmetry because lines of symmetry have two equal sides. These are not two equal sides because my crown does not look the same on the bottom as it does on the top. Okay? And then last but not least, these lovely teardrop looking things. If I asked you to draw or cut your droplet in half here and you folded it, they would be equal on both sides. However, if I asked you to do the same thing right here, and fold it, they're not going to be the same because this side does not have a point like this side does. So this is not going to work because it is not, these two do not look equal on both sides. This looks more like a rounded triangle, and this looks like a semicircle. So this one is not going to work. Okay, please go to either Edge Elastic and work on the assignment that is there today, or you could do it in your paper-based packet, up to you. Please make sure that you're sending us pictures after. And if you have any questions, please let me know. Thank you.